Do you know that I was very shocked when I found out that this two question has never been answered before by any JAMB candidates? And this one here was made attempt in the year 1998, but this particular one has never been attempted or answered correctly. But if you look at these questions, they are gotten from chief topic in chemistry, maybe from the first topic to the first topic. You must see the topic that those questions relate to. Here, the difference with these two here looks familiar in hearing, but also similar, but they are not the same thing we are talking about. Here, talk about the unpaired electron. Here, talk about lone pairs. They are two different things. Now, I'm going to read. Here it says the electronic configuration of an element is what you can see over here: 1s2, 2s2, 2p6, 3s2, 3p3. Full stop. How many unpaired electrons are there in the element? Now, you must remember that once you hear unpaired or paired electron, removing this lone pair, once lone pair is not in it, you are hearing unpaired electron or paired electron. You have to remember the Paulus exclusive principle about electron spin. All right. Now, look at, before we go to that, we have here L, M what, N what, shell, as you can remember. Now, in this shell, they have their sub-level shell, which are the what? S, P, D, F. But I'm going to talk about DF because we just have what? In the electron configuration, S and P is what we can have here. So I'm not going to talk about DF. I'm just going to talk about what? SP. Now, this SP here, which are the sub-level, has their own orbit. You get me? This orbit of S is just single one, whereas the orbit of P is 3, whereby we divide it with what? 1 and 2. We have 1, 2, 3 what? Orbit. Now, according to Paulus exclusive principle about electron spin, it's found out that the electron of an element is going to enter this particular orbit. It's going to enter it with an arrow facing up, upward what? Arrow. And after it has completed to the end of how many orbits is that, is going to return back again with the same arrow but pointing what? Down. For example, if an element has 2 electrons, it is going to, from this S here, has an upward arrow here, below it will have what? Downward arrow. All right. Now, for this one, if an electron must enter here, and this electron that should enter here is what? 5. First of all, we are going to put in what? Upward arrow, upward arrow, upward arrow. After this is 3. We want to fill what? 5. After you have put this up here, you are going to return back again to this first orbit here and bring it what? A downward arrow. You want to put it here. This one makes it what? 4 now. On that one here makes it what? 5. So I've achieved my what? 5 electron at this orbit. Now, this one here that have S here is what we call paired electron. This one here are what? Paired electron, because it is not what? Unpaired. They are what? 1, 2, up and down. Pair means what? 2. And they are paired together because they are what? Up and down electron over here. Whereas this one has what? 1 unpaired electron, which is this one over here. This last orbit has what? 1 unpaired electron. As you can see, no other electron is here to face down, but it has how many paired electron? 1 and 2 paired electron, and this what? P sub level. Now, assuming that this SP represents an element which has 1, 2, 3, 4, 5, 6, 7 electrons. What is the element that have 7 electrons? It is what? Nitrogen. We can see that nitrogen have what? 1 unpaired electron over here. Now, back to this question. It says this is what? Electronic configuration of what? Of an element. Now, I'm going to start from here. This is what? 1s2. So I have S, 1s2. This 2 shows that what? 2 electron. I'm going to put arrow that is going up and arrow that is what? Going one and going down. The second one is what? 2s what? 2. Another what? 1 orbit that is going to contain electron going what? Up and what? Down. These two here I'm putting here are from what? The two over here. It means that this configuration, the element that has it has how many electrons? 2 plus 2, 4 plus 6, 10 plus this 12 plus this 15. 15 electron is what I'm going to what? Arrange as a pair or unpaired electron based on what? Pauli's exclusive principle of electron spin. Now, after we have done with this one, we come to this one, which have what? sp 6. 6 means that there are what? 6 electrons. You know that p sub-level shell has many how many orbits? 3 orbits. So I'm going to put a 3 orbits over here for this one, and I'm going to divide it into what? 3. 1, 2, 3 orbits. Now, because it has 6, first of all, I'm going to put in what? Upward arrow. Upward arrow. It is now what? 3. But I have 6 here. It doesn't mean how many 6. You come again, make the arrow to face what? Downward. That is electron what? Spin from Pauli's law. Completed here. Now we move over to the next subshell, which is still going to be what? P shell. And P shell, we have what? 3p 3. P shell has how many? It has 3 orbits, just like this one over here. 1 and 2. Now we have what? 3 what? Electron to fill in. We have 1. It must goes up first. It must go up first, I mean to say. Now 1, 2, 3 electron correspond to the what? The 3 electron on the third p shell of this what? Particular what? Element. Now if you look at this element is element 15 on the what? Periodic table. Let me know that element that is 15 on the periodic table. Now this element, when you have putting it throughout this electron orbits, you will find out that how many unpaired electrons do you have? Which electrons are not paired? If you look closely from here to here, these are paired, these are paired, these are paired. But this one are just what? Unpaired. They are single. They are still going to contain another electron that is going to come down, but because there is not enough electron to put over to it, it's just going to be like this. Hence, they are what? Unpaired electron. We have how many unpaired electron now? We have 3 unpaired electrons. Now, in this second question, we have how many lone pairs of electrons are there on the central atom of H2O molecule? Now, this we talk about what? Lone pair. This one is very easy. This is a compound which is what? H2, water molecule. Now, for we to have a compound, an element must be able or have interest for what? Duplet or octet rule. Duplet is when they want to complete the first shell, which is what? Having 2 electrons only at each shell. Whereas octet rule is when they want to complete maybe the L, M, and N shell, which must have what? 8 electrons at the outermost shell. Now, for this H2O to come to combine, let's look at the type of chemical bonding they are having. Oxygen has 1, 2 is element number what? 8. So has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. This is oxygen. Oxygen has what? 1, 2, 3, 4, 5, 6 electron at the outermost shell. Hence, it has not completed the what? Octet rule, which must have what? 8 electron at the what? Outermost shell. So it is looking for what? 2 more what? It's looking for 2 more electron. Whereas hydrogen, you can see here, hydrogen is the first element having what? 1 electron. If you want to put it on this care shell, you're going to have 1 electron over here, and this represents what? Hydrogen. Now, hydrogen is looking for what? It is looking for 1 more electron to complete this duplet rule. Now, for water molecule to form, this one here is going to come to combine here. And again, if it combines, oxygen now becomes what? 1, 2, 3, 4, 5, 6 plus this one, 7 electron. Hence, it has not reached this what? Octet rule, which must be what? 8. Therefore, another hydrogen molecule will also come to combine with what? This what? Oxygen. Let's look at the representation. So from here, I'm going to be using only the what? Outermost shell. So this here represents the outermost shell of what? Oxygen. We are going to have what? 1, 2, 3, 4, 5, 6. As we saw that it has what? 6 electrons at what? Atomic share. This is oxygen. Now, hydrogen is going to come to combine with this covalently to form a what? A bond. This represents the what? Molecules of what? Hydrogen. It will now come and combine here. This becomes what? Bonding of what? Hydrogen. And hydrogen combining with this covalently is going to have 1 and 2 what? Valence electron, which has completed the what? Duplex rule, that it must have what? 2 electrons at the care shell. Now another hydrogen, because we have H2O, there are 2 what? Hydrogen, is going to come this side, combine with this other what? Electron here, so that the two are going to be sharing what? They're going to be sharing their what? Electron. Hydrogen brought 1 electron and oxygen having 1 electron. When they share the 2 electrons, hydrogen here is going to have 2 valence electron, just like this one has 2 valence electron. Hence, hydrogen has now been certified with what? The duplex rule of care shell, that says that the first shell must have what? 2 electrons. And oxygen here has also completed what? The octet rule. We say that what? The LMN and so on shells must have what? 8 valence electrons. Let's check. 1, 2, 3, 4, 5, 6, 7 what? 8 valence electron. Now the question says, how many lone pairs of electrons are there on a center atom of the H2 molecule? These are the what? H2 molecule. Now unpaired electrons here are those electrons that did not combine or that does not take part in the what? Chemical combination or in the chemical bonding. As you can see, what are those electrons that did not take part in this chemical bonding? There are this one over here and this one was over here. But the question now look at how many lone pairs. How many lone pairs? Is it 1, 2, 3, 4 like this one? Or is it 1, 2, 3 for here? Or is it 1, 2, 1, 2 for here? Or is it 1, just like you can see? Which of these is correct? Now, what do we mean by pairs? Pair means what? 2 things. So how many what? Lone pairs. How many lone pairs? We are not looking for what? Lone electron. We are looking for what? Lone pairs. So there must be what? 2 lone pairs. 2 electrons to form a what? Pairs. So how many of those lone pairs, 2 electrons that form pairs, do we have in the H2O molecule? Hope you understand. How many pairs are what? 2. 2 things make up what? Pairs. So how many lone pairs? How many of those 2 things that make up pairs do we have on water molecule? So this one here is a pair 1. This one is also a what? Pair 2. We have how many now? 2 lone pairs. So this here is the correct answer. Once you see this question again, don't forget to quickly make a diagram using what you have over here. You get the correct answer. Let me know what you think on the comment section. If you have other difficult question or something you want me to make you enlightenment on, let me know in the comment section. I'm Mentor Body Around Academy. Don't forget to share this video to your friends, like, and also comment on the comment section. Very, very important. See you next on my next video. Bye bye.